A very good evening, everyone. Welcome back to our session on Power BI and data analytics with AI. So it's our day 4, and today we are here with a new topic. So far we have understood the concept of Power Query Editor, right? So in the past two classes, we have understood what is the purpose of Power Query Editor in Power BI. Am I right? Yes. So what is the purpose of Power Query Editor, guys? Why do we use Power Query Editor? In order to perform transformations, the cleaning activities, we go and use Power Query Editor, the first component of Power BI. Then coming to the next component, it is Power Pivot. What it is? Power Pivot. Why do we use Power Pivot? In order to make relations among tables or in order to build data models. In order to make data modeling, we use Power Pivot component of Power BI. Okay, so if you observe, data models are nothing but we are able to establish the relationships among the tables, among the data, different tables. If you are able to establish relationships, okay, so that is nothing but data models, and we can have the relationships clearly understood in model view. What is this view called? This is called model view. And in today's class, we are going to understand how data modeling should be done. Okay, how can we perform data modeling in Power BI using Power Pivot component, and followed by we'll also try to understand the next the next concept, DAX. Okay, so that will be the agenda for the day. Okay, so two important components, two important concepts in Power BI. Pay attention, guys, across the session. So I'll start with the first one. It is Power Pivot. So in order to understand Power Pivot, I should take you back to a real-time scenario. Because if you understand how the data is stored in real time, then you'll understand why should we use Power Pivot component. What is the purpose of using Power Pivot? Okay, right. So let me launch Excel, my Excel workbook. It's taking time. Yes, I'm going to take a new Excel workbook. Okay, in order to explain the concept of Power Pivot, the data models. Right. So in general, you know, the data in real time, wherever you see in the real market, okay, the data will be stored in normalized fashion, guys. It gets stored in normalized fashion. What is this normalized fashion? We'll understand. But what if the data is stored in denormalized fashion? What if the data is stored in denormalized fashion? What are we supposed to do? Is what we are going to understand now. Okay. So let us understand the differences between normalized and denormalized. But before that, I want you to understand what is denormalized data. Okay. Why the data should not be stored in denormalized fashion. Okay. Or denormalized way. Why the data should only be stored in normalized fashion is what we are trying to understand initially. Then You'll understand how the relationships can be established among the tables, among the queries. Okay. So let us understand what is denormalized data. What is meant by denormalized data? Let us understand this. Data, I'll give an example. If my data is like this, see, assume I have a company, okay, and within the company I'm storing my employee details, okay. If I'm storing the details of the employees, and here is a table which is going to talk about the employees belonging to one specific department, okay. So I'll just give an example. So probably the details of the employees are like this: serial number followed by name of the employee. Then next to that we have uh, department of the employee, then department manager or team lead, okay, then department mail ID, okay. So if I have, I'm just talking about, the details of one specific department, guys. I'm talking about the details of the employees who belongs to one specific department, right? So assume I have uh, 5 employees, okay, 1, 2, 3, and 4 and 5, okay, and the names are like this: A, B, and C, D, and E. So these are 5 different employees who work in the same department. Probably I'll keep it as sales. All of them work under sales department. Okay. And if all the people work on the same department, will their department manager be same? In general, yes. So the department manager for sales is said as Abhi or Abhinay. Okay. So what should be the values for rest of the folks? The manager should be seen. It is Abhinay. And there is a common ID, there is a common mail ID for the department. It is like abc@xyz.com. Okay. Assume this is my mail ID, the department mail ID for sales department. Assume. So this is how I have my data, guys. This is how I am storing the data of employees who work in my organization under sales department. Now tell me, do you find anything wrong here? I'll give you a good amount of time. Try to understand the data that was provided. Okay. And this particular table is especially holding the records, the information of the folks, of the employees who work in sales department. Okay. Now tell me, should I continue in this similar approach or should I change the way I am storing the data? What do you see? Because I have the first column is talking about the number of employees, the serial number or employee ID, whatever it might be, then followed by the name of the employee, then the department to which they work for, department manager, and finally we have department mail ID. Okay, so tell me, put some comments on the data that was provided to you. What do you see? Storing the data in this way, in this approach, is good or bad? Should I continue storing the data in this fashion or not? If yes, why? If no, again, I want your justification. Your answer should be justified. Yes, answers. What do you say? If you ask me, if you ask me, should I continue storing the data in this approach or in this fashion? I say no. The reason why it is, this particular table has a lot of redundancy. What do you mean by redundancy? Redundant data is more. Redundant data is nothing but data duplication is more. If you observe, yes, that is nothing but, duplication. Exactly, good. Most of the information is common. What kind of information is common? Department is common. The name of the department to which the employees work for. Yes. Their department manager is also same. Yes. Then what else? Their mail ID is also same. Why? Because they work for the same department. So what I can comment here is, I can clearly understand that most of the data is redundant, which is consuming more memory. When it consumes more memory, more space, what happens? The performance comes down. We know that there is a trade-off between, you know, performance and storage or memory. What do you say, guys? As it is, storing what of space, as it is, this particular table is storing, it is occupying more space, the performance will be coming down. So such kind of data is nothing but denormalized data. Why do you say denormalized data is? This data has a lot of redundant information. What is the use of keeping all this redundant information? So what do you mean by that? So does normalized data have zero redundancy? No, I didn't tell that. Right? I mean to say that normalized data will have less redundant information compared to denormalized data, guys. Denormalized data have a lot of redundant information, whereas this redundancy, the duplication can be, we can make it down by converting this table to normalized data. Okay, so in general, why the data is not stored in denormalized fashion is, when you store data in denormalized fashion, it actually results in three main anomalies. We are going to face three main anomalies. What are they? They are, we get up, anomalies because of insert, update, delete. So we are going to face errors. Anomalies are nothing but errors. Okay. So we are going to face errors or anomalies because of inserting the records, updating the records, or deleting the records. Because of storing the data in denormalized fashion, in general, we can face, three main anomalies. What are they? Insert anomaly, update anomaly, and delete anomaly. Let us understand how are we going to face these three anomalies. Assume that if a new, for example, if I'm going to hire a person for the same department, okay, for the same sales department, if I would like to hire a new person, what I'm supposed to do? I'm supposed to store the data of the new person, new employee. Yes. To the same table. Yes. So it will be like 6. F, department will be same. Their department manager will be same. Department ID also will be same. So what's happening when the number of employees, nothing but when you are inserting new records, what's happening to the data? The redundancy is increasing. It's not decreasing. Unnecessarily, we are storing the same information, right? So that is leading to insert anomaly. That is leading to insert anomaly, right? Let us understand how we face update anomaly. Is assume that Abhinay have resigned for the company. This person have left the company. Resigned and left. Okay. Now, will obviously hire a new person. Yes, companies will not keep their positions, their critical positions vacant. So the department manager for sales we got a new person hired, and her name is Priya. Her name is Priya. So should I change the department manager details for only one person or for all the persons in this table? Come on, guys. I have to do the same for all these people. So that means whenever there is a change with respect to manager or ID, are we just storing the data in one such record? No. You have to make the changes wherever the person name is. See, here instead of changing in one separate table, what am I doing? I'm supposed to change the department manager for all these employees. So this is leading us to update anomaly. Update anomaly. And finally, delete anomaly. Okay. So when the employees start leaving the organization, assume, one by one of the sales department, the employees in the sales department started leaving our company. Assume. Okay. So once the company, the employee leaves, what I'm supposed to do? I have to remove the data from the table. F left, removed. E left, I have removed. In the same way, D has left, removed. Okay. Then C left, the details of employee C has been removed. B left, data has been removed. And finally, A left. Assume. If this is the case, what are we doing? Whatever we have done is right, because once the employee leaves, we are supposed to remove their data from our table, right? But we are also losing the important information. What is the important information that we are losing here? That is the department manager for sales. Who is the department manager for sales? So that important information we don't have in the table. As one by one employee left, we have removed the data from the table. Accepted. Okay. But this is also removing, this is also deleting the important information, like the department manager for sales, the sales department common mail ID. Where is the details? So that will lead us to delete anomaly. This is called delete anomaly. So these are the three anomalies that we face when we store the data in denormalized fashion, guys. When you store data in denormalized fashion, it will lead us to three main anomalies. What are they? Insert, update, and delete. Insert, update, and delete. So that is why in real time, no such organization stores the data in denormalized fashion. How do they store the data? They store the data in normalized fashion. So does normalized fashion, if I store the data in normalized way, is it going to solve all these anomalies? Yes. Yes. Okay. So we'll understand how this same table, the same data can be stored in normalized fashion. How that can be done, we'll understand, guys. I hope it is very clear till here. Whatever we have discussed so far is very important. So quickly, I'm going to give you the summary of whatever the points that were covered so far. In general, you cannot expect the data storing in denormalized way. Okay, what happens if the data is stored in denormalized way? It will lead us to three main anomalies or errors. What are they? Insert anomaly, update anomaly, and delete anomaly. Okay, so what do you mean by denormalized data? Denormalized data is nothing but the data in which where you'll observe majority of the information getting redundant. Okay, duplication. Unnecessarily we are storing the same data time again. See, so this will consume more memory, more space. When it consumes more space, obviously the performance will be affected. Right? So that is where the denormalized data will be converted to normalized data. So now taking the same data, let us do it, guys. Let us convert it into normalized fashion. Okay. So I'm going to take the same data. I'll be converting into normalized fashion. How? We'll do it. So I'll take all the details of the employees who work in the sales department and I'll store it in one such table. And I'll also take the details of the department, sales department only. See, done. What did we do? What did we do, guys? Did I do anything additional? No, nothing. What I have done is I converted my denormalized data into normalized data. How? By just breaking the table. Whatever the data that I have, I just made it into two parts. So this table talks about the details of the employees who work in sales department. Yes. What about the other table? The other table talks about department details. Department details. So in this particular table, you can have the details of all the departments, sales, engineering, marketing, finance, HR, etc. Yes. So the department name followed by the manager and the common ID. Okay. So, excuse me. So what can I observe here? I see the data getting normalized. How do you say it is getting normalized? If I observe properly, earlier majority of the information is getting repeated. Unnecessarily we are storing the values of department, department manager and department ID. But now I'm just repeating only the values for department. So does the redundancy got reduced? Yes. Redundancy is not becoming zero here. It is there. See, if you observe, department name is repeating. But comparatively, if you compare denormalized data and normalized data, the amount of redundancy got reduced. When it is occupying less space, less memory, obviously the performance will be high. Okay, then the second point that I would like to talk about is anomalies. Anomalies. When I converted the data into normalized fashion, are we still facing these anomalies? Let us understand. What if a new person, if I hire a new person, a new employee for sales department? Okay, if I hire a new person for sales department, what am I repeating? I'm just repeating only the department name. Earlier, I should also repeat manager name, and their common ID. So Are we still facing insert anomaly? No. When I try inserting new records, okay, comparatively, I don't face that kind of error. And if I want to update a record, okay, in the same case, if the manager leaves, if a new person is hired as a manager, should I update like for the entire column? Not required. If I update here, it's done. So in this way, are we also going to get rid of update anomaly? Yes. What about delete anomaly? Even though if all the employees leave under the sales department, if all these employees leave under the sales department, I can still have the important information. Are we losing the information of the department manager for sales? No. The department ID for sales? No. So I'm just overcoming the challenges that I have faced when the data is stored in denormalized fashion. Right? All of these challenges got rid of by storing the data in normalized fashion. Okay, so this is why the reasons behind the data is stored in normalized fashion. Why not in denormalized fashion? I hope it is very clear, guys. Once if you have the data in normalized fashion, you can establish a relationship, right? See, there is a common column. What is a common column between the tables? Department. So why don't we establish a relationship? We can establish a relationship between department columns, between table 1 and table 2. Once after establishing the relationship, I'll have the connection. So this is how this is called as data modeling. So when you do data modeling, it's nothing but you are establishing the relation between the tables. How? Using the common columns like department. Okay. So in this department, I mean in this two tables, there are two important terminologies called as fact table and dimension table. Fact table and dimension table. So what is this fact table and what is this dimension table called? Fact table is nothing but the table that we change very rarely. Okay. So if you observe, tell me out of these two tables, which values do you often change? Probably table 1? Yes. Say if if there are 10 employees under the sales department, any of the employee can leave? Yes. Or we can also hire a new employee for the sales department? Yes. So when we hire or when a person leaves from the sales department, for sure the records have to be changed. For sure the records have to be changed. Am I right? Now, in the same way, how often you are going to change the records of table 2? Will you keep on changing table 2, the department details table? Come on guys. Which table do you change very rarely? Obviously, the table 2 will be changed very rarely. The reason behind that is, you know, only if the department manager leaves. See, only if Priya leaves the organization, we are going to change this table. Or if the ID is, we are if once in a decade or once in 2 decades, if you are changing any IDs, only then you'll be changing. In general, you'll not change. Am I right? So comparatively, there are many chances of changing the records in table 1 compared to table 2. right? So, so that's what I'm telling. You will change, see, only if the department manager like Priya leaves, okay, you'll be changing this table. Yes. What if you change the department mail ID? Yes, obviously you can change. But will you do every 1 week? Or will the department manager leave for every 1 month? No, right? So, in general, you'll be changing these records of table 2 very rarely compared to table 1 because there is lot of chances for changing the records of table 1 compared to table 2. The reason behind it is an employee under the sales department can leave or we can hire a new person for the sales department. So I can change table 1. The chances of changing performing the editing the table 1 is more compared to table 2. Am I right? What do you say, guys? Yes. So such kind of table is called, you know, fact table. This is called fact table and this is called dimension table. This is called dimension table. The table which is oftenly changed is called fact table and the table which is rarely changed is called dimension table. And you can have multiple dimension tables. Okay, you'll be having multiple dimension tables, guys. I'll show you how the schema looks like. In general, the schema is represented with star. I have to draw the star schema. I should explain about the star. So how do you have stars? In this way, yes, this is how you're going to have stars, right? So in the middle, you'll be having your fact table and on the other sides, you will have the dimension tables and you will be connecting these dimension tables with the fact table. So this is what you are going to do. This is what you are going to do. Okay. So this schema is represented with star. It is compared with star. So that is the reason it is called as star schema. It is named as star schema. Right. So we'll be taking an data set and from scratch we will be understanding whether the data is in denormalized fashion. If the data is in denormalized fashion, we are going to convert the data into normalized fashion and we are going to establish the data model in this way. At the end, our aim is to create data model. So is this a data model? Yes. Okay. So we are establishing the relation between the tables. Between the normalized fashion tables, we are going to establish the relationship. So this is what we are going to create, guys. How? Using the component power pivot. Using the component power pivot. Right? So let us do this entire thing in Power BI desktop. Okay. So for that, I have took a new file. New Power BI file is what I have took. Right? And I'm also changing the data set. I'll go with, yep, store data. Let me talk about the data set first of all. So this data set is related to a superstore. Okay. So let us understand first of all the data set, guys. Right. Yes. So what do you observe in the data set? Initially, you observe the IDs, sale ID, product ID, customer ID. store ID and date ID. Okay, all of these are representing IDs, unique values. And next to that, we have some columns. What are the columns that we have? It's like, quantity, the amount of, the total quantity of got sold, and the total amount. Next to that, we have product name. And what do you observe with respect to the product name? Do you observe anything fishy? In a sense, do you observe the product names getting repeated? Yes. If you observe record 8 and record 9, what is the product ID 104 and 104? What is the product for ID 104? It is winter jacket. Okay. So is it the same? Yes, it is same. But since this product was sold in two different sales, I mean two different orders, we got the same ID. The product ID is same, the product is also same. And the category will also be same because for each and every product, it will be made into categories. So it belongs to some furniture category and the price for it. Price for the jacket followed by who is supplying that jacket. And what is the stock quantity for the jacket? What is the rating that we got for this product? So if you observe, I can clearly understand all these values. Sorry. Yes, all these values I'll be highlighting some values. Observe guys. What do you think? Do you think are these getting stored unnecessarily? Yes or no? See, the product ID is 104. The name of the product is winter jacket. Okay, it belongs to furniture category. The price is $83. Okay, supplier is some XYZ guy. And the stock quantity for the winter jacket is 214 number. And the rating that we got for the product is 3.2. But why it was repeated for two times? Because of two sale IDs. I mean, two different orders, two different customers have purchased it. So I can clearly understand there is redundancy in the data. There is redundancy in the data with respect to products. Yes. Let me go a bit further. I'll go next to it. What is the next one? Store name. Oh, if we observe, the name of the store name is Downtown Depot, and even in the second record also it is same. Even in the second record it is same. Okay, let us check whether these both are same or wrong. Are these both same or different? What is the store ID for Downtown Depot? Here it is 381 and next to it it is 378. So that means they are not same because two different IDs. Anyways, what are the columns that are talking about stores? Are next to store name you see location, the location where we have that store. It is San Francisco. Okay, same. The location is also same guys. Who is the manager? Even the manager is also same. But if you observe open year, the first one got opened in 2004 and the second one got opened in 2005. So that means they are not the same stores. They're not same stores. Why? If they are same, assume that store ID is by default, assume it is wrong, wrongly mentioned. But here it is giving the clarification. What do you understand? I can understand clearly that the name of the store is same, but they got opened in 2 different years. The store size is medium, the revenue is some around 0.7. Okay, so even though if these all are same, the open air is making them different. So that means they are not belonging to same, they are not representing the same store. But still I see some records are, some of them are falling under duplication. They're getting redundant. We'll understand. Next to store data, we have customer related data, customer name. Can you find any duplications with respect to customers? Yes, we can. The reason behind that is, can you tell that a person or a customer will purchase only once from a store? No, it depends, right? So if the customer is satisfied the service or if the customer is satisfied the products, okay, then obviously the customer will purchase for n number of times. Okay. So next to that we have customers details. See, customer name, customer gender, customer age, customer city, customer membership level, then customer spending score. So in this way, we have many columns which are talking about customers. So for sure, I feel there might be similar kind of customers. We'll figure it out, guys. And finally, we have date related columns. Yes, I can clearly see, the data is in denormalized fashion. We have to make it normalized. We have to make it normalized. Majority of the data is getting redundant. It is repeated. So we'll take this data set and we'll try to understand the real-time exposure of the data modeling. How the data modeling will be done. Okay. How a table or how a data which is present in denormalized way can be converted into normalized data, and how the relationships can be established is what we'll be understanding, guys. So I'll take this data set. I'll launch Power BI desktop. Done. Power BI desktop has been launched. Then how should I load the data? First of all, how should I load the data? As we have the data stored in an Excel file, okay, so there are multiple ways, multiple options. I'll directly go and use the simplest one. I'll click on the Excel workbook option under the home tab. Okay, so this will launch me, I'm supposed to navigate to the file where I have the Excel workbook. Once after it is done, select it, then click on open. Now, what happens? The navigator window gets opened. The navigator window gets opened. Within the navigator window, we are supposed to select the sheet. We can go and click on the, we can go and have the preview of the data. Yes, see, anyhow, I have only one sheet. Within this store Excel workbook, there is only one sheet, guys. Let me anyways cross check. Yes. So this is the data that I am going to work with. So should I click on load or transform data? Always recommended to go with the transform data, because if you would like to do any kind of transformations, you can complete it off using Power Query Editor, and then you can come back to Power BI desktop. So I'll click on transform data option. So this will launch me Power Query Editor directly. The data gets loaded to Power Query Editor. See, what are tables called in Power BI? What are tables called in Power BI? They are called queries. See. So is this the data that we are going to work with? Yes. So this is the data that we are going to work with. So first of all, you have to check, you have to go through the data in such a way that how many different tables can we bring from this original table? How many different tables can we bring? Like what we have done in this case, from this table, from the original table, we have broken the table into two parts. We broke it into two parts. Table 1, table 2. In the same way, you have to go through this table in such a way that by understanding the data, you are supposed to build the tables. That means this denormalized data should be transformed into normalized fashion, normalized data, right? So what I'll do is, first of all, let me create duplicate of this table. How can I create duplicate of this table? Under the queries section, when you click on this, when you right click on the table name, the query name, it will give you a list of options in which you will find both duplicate and reference options. So duplicate and reference will create duplicates. I'll talk about duplicate and difference, the differences between duplicate and reference options. So let me first create a duplicate of the table. So this is duplicate of the table, guys. And let me create a reference of sheet 1. Do you observe any differences between the duplicate and the reference? This is duplicate in which you see 4 steps. Under the applied steps you see 4. What about reference? No, only one. It is referencing to the source. What is the source for it? It is nothing but sheet 1. So what will happen here is the difference between duplicate and reference is nothing but when you do changes in the duplicate table, or sheet 1 is your original table. Yes. When you do changes in your table 1, that is nothing but sheet 1. Okay. The changes will not be made in sheet 1, that duplicate table, whereas the same changes will be repeated in the referencing table. Shall we do it? Shall we understand? Yes. See, for easy understanding, in the main table, I'll remove one column base. I'll remove the sale ID column. Removed? Yes. Sale ID column got removed. Let me go and check the duplicate table. Is the sale ID column got removed? No. No. What about the referencing table? What happened? Do you see sale ID? So it got removed. That makes the difference between duplicate and reference. Good. Guys, see, you are supposed to understand the difference between duplicate table and referencing table. A referencing table will always reference to the source, whereas duplicate will not. Okay. Anyways, I'll undo this step. Done. Now, I'll also delete this referencing table because I don't want referencing tables. I just want only the delete, duplicate tables. So let me go with the duplicate table, the first duplicate table. Let me try to keep all the columns related to products. Let me try to keep all the products, all the columns related to products. You see product ID? Yes. So let me select product ID. Next to product ID, you see product name. Select product name because product name is also a part of product ID table only. I mean products table. Then category, price of the product, supplier of the product, stock quantity of the product, and rating of the product. Yes, we are done. So these are the columns that are related to products. And I don't want to have other columns. I just want to have only the columns related to products. Remove columns. Should I remove the selected one or the unselected one? I would like to remove the other columns. So this will allow me to have only the columns related to products. See, I had only columns related to products. Yes. Now observe carefully. Do you find any duplicates? Yes, I can clearly see there are duplicates. See, winter jacket, whatever that we have discussed, it is a duplicate. See, in the same way, you will have multiple duplicates, guys. See, office chair, even winter jacket is repeated one more time. Okay, so in this way, there are duplicates in the data. As we are trying to convert the denormalized data into normalized data, you are supposed to reduce the redundancy. The duplication has to be reduced. How many rows we have? In total, 100 records. So, I am supposed to remove the duplicates. In Power BI, we do it by selecting a column. How the duplicates will be removed, Select a column which does not contain any duplicates. Which cannot contain any duplicates. Can I select product ID? Yes. ID for a product should be unique. So I'll select product ID column and I'll remove duplicates. So that means whatever the repeated values that we have in the product ID gets removed. See what happened? 100 became 20. See, 100 became 20. Now you try to find the duplicates. From this table, try finding the duplicates, guys. It is not possible. Why? We have removed. So in this way, I'll try to build the other tables also. I'll try to build the other tables also. First of all, I'll rename it as product table. I'll rename it as product table. Done. Then I'll go back to the original table. Can I also create a table for customers? Yes. So let us create a duplicate of the original table. I'll create a duplicate of the original table. Okay. So within this original table, I'll collect or I'll have only the columns related to customers, customer ID. Then all of these are related to products, store names, location. No. Yes. I see the columns related to customers, guys. Customer name, customer gender, customer age, customer, location, customer's membership level, and finally the spending score of the customer. So these are the list of columns that are related to customers. Okay. So let us remove the other columns. Similar, whatever you have done so far, you'll be removing the other columns. Why? Because let us have a separate table for customers. And from this, can you identify the duplicates? Yes. Obviously, there will be duplicates. See, if I'm a customer of the store, will I place the order only for once? No. It may or may not. See, if you are well satisfied with the products, the delivery, the service, obviously we are ready to spend more. Right? We'll be spending good amount of money for our lifestyle. Right? So that is what we'll be doing here. So I'll take the column which cannot contain the duplicates. It is nothing but the customer ID, because customer ID should be unique. So based on this column, I'll remove duplicates. I'll select the column, then I'll remove the duplicates. Done? Yes. 100 became 68. So that means 68 customers data is what we have. Okay. So 32 records got removed. Now I'll rename it as customer table. Done. I'll rename it as customer table. Is there any chance of creating any other tables? Go and check. We have created product table, customer table, store table, because we also have columns related to stores. So let us identify the columns related to stores, and why don't we reduce the redundancy? Because we may have the stores details repeated, right? So I'll create a duplicate of the original table, and I'll have only the columns related to store ID. I mean the stores. Store ID is one of the column. Then what are the other columns that are related to stores, guys? Stores, yes. The store name. Store name obviously belongs to store. Store location. Then store manager. The opening year of the store. Store size. The revenue that gets generated from the store. So all these are the columns that are related to stores. All of them are related to stores. So what I'm supposed to do? Again, remove the other columns. Do the same. Under the home tab, you'll have remove columns option. Just go and select remove other columns. This will remove the other columns that are not selected, that are unselected. Apart from the selected columns, the other columns get removed. Done? Yes. Okay. Now you are supposed to identify whether we have duplicates or not. Yes, obviously we may have duplicates, because see, are you sure that this 100 records, they contain the details of 100 different stores? Not exactly. There might be some records that are talking about the same stores. Yes, there might be a chance. So how can I remove the duplicates? I can remove the duplicates by selecting a column which cannot contain duplicates in general. It is nothing but the store ID. ID means an identity for any given thing. So store ID means unique identity number given for stores. So I'll right click on the store ID column, then I'll remove duplicates. What happened? 69 rows is what we left out with. That means 31 records got removed. We had duplicates and those got removed. Now you will not find any duplicates. Go and check. You will not find any duplicates. So I'll name it as store table or stores table, whatever it might be. Done? Yes. Is it possible to create any other tables? Go and check. Created product table, customer table, stores table. Do we also have any columns related to transactions which represents dates? Yes. Yes. There are columns related to dates like date ID. If you go to the last, all of these are columns related to dates. Date, day, month, year, weekday, quarter. So within a specific day, can you expect multiple orders? Obviously. Within a day, you'll get only one single order. No, right? You'll get multiple orders. So let us remove the duplicates with respect to the dates as well. I'll create a duplicate of the original table. Now, I'll start selecting only the columns related to date. Date ID, and I'll go to the last guys. It is like date column on which day we have got the sale transaction done. Then the day of the specific date, the month of that specific date, year of the specific date, whether it is weekday or not, which quarter to that specific date belongs to. All of these are nothing but the columns that are related to date. Now I'll just go and remove the other columns. I'll go and remove the other columns because I would like to keep only the columns related to dates. Okay. How many rows we have? By default, you'll have 100 rows because the original data contains 100 records. Now, let us try to remove the records, the duplicate records, by identifying the orders that we have received on the same day. How can I do it? We have date ID. Yes. So if the date ID is common, that means that particular order has been received on the same day. Am I right? See, assume on Sunday you can expect multiple orders. Yes. Because many of the people they will be free on Sundays or weekends. So I'm just giving an example, guys. We are trying to identify the dates where we have the duplicates because if the date ID is same, obviously the date will be same, the day will be same, month will be same, year will be same. So all the columns will be same across the same date IDs, which represents those orders are received on the same date. Okay, so let us remove the duplicates with respect to date ID. Select the column and remove the duplicates. Oh, 70 records got removed. That means only 30 of them are unique. Now, the dates table contain the transactions, the dates, okay, which represents the transactions on which date we got, which date is, month, so on, without duplicates. Is the data getting redundant here? No. We are reducing the redundancy. What is the purpose of normalized data? To reduce the redundancy. Done. Yes. Let me go to the original table. Yes. So this is my original table, right? Now, we have created 4 different tables from the original table. One is products table, customer table, store table, and dates table. Dates is nothing but the transaction dates. Okay, right. Now, what I'm supposed to do? I'm supposed to establish the relation between the original table and these other tables. For establishing the relationships, what you like to have, you should have a column, a matching column. Okay, like see, in our example, we have department as the matching column so that I can keep the relationship. I can establish the relationship. In the same way, try to include only the columns which can establish the relationship. Like product ID has to be included, customer ID has to be included, store ID has to be included, and date ID has to be included. Why? If I have all of these four, okay, I can establish the connection between the original table and the other tables that we have built. Product ID, if I have product ID, I can connect with product table. If I have customer ID, I can connect with customer table. Store ID, I can connect with store table. Date ID will connect with to date table. So what I'll do is I'll select a few columns which help me to, you know, establish the connection. What about the other columns? I'll drop. There is no purpose of keeping the other columns. Why? Rest of these columns information you already have in these tables. So that is where a denormalized data is being converted to normalized data. See? Done? See guys. I just had only 7 columns in sales. I'll name it as fact table. This is my fact table. Why it is fact table? Because I can have multiple sales orders coming in. So this table records will keep on updating. But what about these table records like product table, customer table, stores table, dates table? They will be updating once in a while. So these becomes dimension tables. But fact table becomes, the first one becomes a fact table. The reason behind this, on a single day you can expect multiple orders. Until unless if a new customer comes, only then you will change the records of customer table. Only if a new product comes into your picture, into your store, only then you'll change the records of product table. Right? So this is the changes will be done very rarely in the dimension table. But within the fact table, the changes will be done very oftenly, guys. Right? So this is where we have created fact table and the dimension tables. And if you observe, there is no redundancy. There is redundancy, but compared to the data that is present in this way, see, earlier the data is present in this way, where the data is stored in denormalized fashion. The same data we have converted it to normalized data by keeping the data in 5 different tables. If you compare, you'll understand. The amount of redundancies also got reduced, guys. Now, what you are supposed to do? Whatever the transformations that you are supposed to do, you are done. Just click on close and apply. Under the home tab, you'll observe close and apply. What happens if you click on close and apply? When you click on close and apply, it will close Power Query Editor and all your changes, all the queries will be applied to Power BI desktop. Let us do that. Observe guys. So it takes good amount of time initially for loading. So it is loading all the 5 different tables. product table, customer table, store table, dates table, and fact table. All of them got loaded. It's taking time. Let us wait. Yep. So focus under the data pane. Do you observe all the 5 different tables? 5 different queries. Yes. All the 5 different queries were being loaded to Power BI desktop. And if you observe, under the data pane, all these tables are arranged alphabetically. They are arranged alphabetically. See, customer table coming first, then dates table, fact table, product table, and stores table. And let us cross check whether all the columns are also related to the table or not. Yes, under the customer table, we have the columns related to the customers, and these are the different columns followed by you know the other the columns for the dates table, fact table, product table, and finally for stores table, right? So these are the different tables that we have created. And now what is our task? We have created everything. We are done from our side. So initially our data is in this fashion. Okay. What we have done? We have created the data into 5 different tables like this. The data redundancy got reduced, and now we can see that the data is stored in normalized fashion. Once after having the data in normalized fashion, can I establish the relationships? Yes. Where you can go and establish the relation between the tables is, you see, this is called report view. Next to the report view, you'll have table view. And next to table view, you'll find model view. So what is the purpose of model view? Model view allows us to establish the relationships between the tables, between the queries, right? So I'll go to the model view, guys. I'll just go to the model view and I'll close these panes. What happened? I can clearly see that the relationships also got established. See? Did I create these relationships? No. Who created these relationships? Power BI has done that, guys. Power BI is intelligent and it is capable of identifying the relationships. Okay. And these relationships were being created by Power BI only. Okay. So what I'll do is I'll adjust them properly. Product table, stores table, then I'll keep the fact table here. Okay. Then I'll bring dates table to the right side. And customer table down to it. Yes. Do you observe that star schema? So what I have done is, initially my data is in this fashion, which is called denormalized fashion. And I took the data and I have converted into normalized data, and I tried establishing the connections. The relationships were being established. This is called data model. This is called data model, right? So what is the purpose of this data model? Is even though if you observe, when you hover on this connection, it is identifying some columns. See, when I'm just hovering my mouse on the connection, immediately it is identifying the column via which the two tables got connected. So dates table and fact table, they are connected using date ID column. See, customer table and fact table, customer ID column is the one which has made the relationship. Store ID, store table and fact table, store ID is what it is connecting. And product ID is the column which is connecting products table and fact table. So Power BI being intelligent, it will automatically detect all these connections. What if Power BI did not detect the relationship? Assume. In very rare case, if Power BI did not detect the relationship, how you are supposed to establish the connection? If you get a such kind of question, I'll tell you. Let me first of all delete one of the connection. I'll delete one of the connection. Now, see, there is no connection between dates table and fact table is, if you observe. Right? Now, what if I want to create a relation between fact table and dates table? One way of doing it is identify the column which is common, date ID. So now take this date ID and leave it on the fact table. Immediately you'll get a pop-up window asking you to establish for new establishment. Okay, it will give you a pop-up window where you are supposed to select the column names. See, what is table 1? Dates table. What is table 2? Fact table. So what is a common column? It is date ID. Date ID is the common column which is used for establishing the relationship. And what is cardinality? Cardinality means the type of relationship. Cardinality is talking about relationship, and by default you will find four types of relationships. It is one to one to many to many, and many to one. We'll understand what are these relationships. It has selected one to many. It has selected one to many relationship, and cross filter direction is identified as single. What is this cross filter direction? You'll understand. Then if you click on save, this will establish a relation between dates table and fact table. This will establish a relation between dates table and fact table. And even though if you have noticed earlier what type of cardinality it has identified one to many, one to many. Okay, so that means many is represented with star, guys. Many is represented with star. See, with all the tables, what kind of cardinality exists? One to many only. See, what is this one to many relationship? One to many relationship is nothing but if you take one specific value from, assume that if you took, I'll take product ID. For a easy understanding, I'll take products table. Between products table and fact table, what is the column that is allowing us to keep the relationship? Product ID? Yes. If I take one product ID from the product table, how many, the same number of, that specific product ID, you'll observe n number in fact table. You'll observe them in n number, right? Because in product ID, there are no duplicates. But in fact table, within the product ID column, there are duplicates. So that is representing star. Star is not actually representing the duplicates. It is representing many. One to many relationship. For one value, if you take one value in the product table, what does one value represents? One specific product ID. That product ID can be part of multiple sales. Yes. I purchase laptop, guys. There are also a number of people who also purchase laptops. Yeah. So that is representing one to many relationship. In the same way, if you take one specific date from dates table, within the same day, there might be n number of transactions, n number of orders that might have received. Here, one customer ID, if I take my customer, if I assume that I am a customer of this specific store, I have a customer ID. Yes. So within this table, I'll be present for how many number of times? Only once. If I take myself, I can be present in this table for n number of times. Yes. Why? I might have placed n number of orders. So that is representing one to many relationship. That represents one to many relationship. The best example that we give is, if you take a student has to, study a number of subjects. For graduating, you need to study a number of subjects, right? So that is a one to many relationship. One student studying n subjects. Okay, so all of these are actually going with one to many relationship. Okay, let me talk about all the four relationships. One to one, the different types of relationships that we have are one to one to many, then many to one, and many to many. So these are the four different relationships that we have, the different types of cardinalities. I'll explain all these relationships taking one by one. One to one relationship, the best example that I give is, you take, uh, you know, person and their Aadhaar card or PAN card, Aadhaar ID. Yes. So tell me, if you take one person on the, from our country, okay, so will all these persons, will they have multiple IDs? Multiple Aadhaar IDs? No. You take any person, they'll have only one specific Aadhaar ID, Aadhaar number. What if a person has multiple Aadhaar numbers? Then he'll be put in bars or she'll be put in bars, which is a crime, right? So this is called one to one. One person will have only one Aadhaar ID, and even if you go in the reverse direction, one Aadhaar number will be connected with only one person only, guys. This is the best example that we can give for one to one relationship, right? And if you observe one to many or many to one, both are quite opposite. Okay. So example, student and subjects. One student has to study multiple subjects, right? A student has to pursue multiple subjects. In the same way, if you reverse this, you'll get the example for many to one. Then coming to many, so probably it can be given like this. Doctors and patients. A doctor can go and perform operations for multiple patients, or a doctor should look after multiple patients. Yes, in the reverse direction, a patient can also be, you know, consulted by multiple doctors. Yes, so this is the best example for many to many. All these are representing the types of relationships between these tables. The different types of relationships is what we are trying to understand, right? So within our example, if we observe, all of these are representing one to many relationship only. One to many relationship. How is many represented? Many is represented with star symbol, whereas one is represented with one. Okay, so that is what we have with respect to cardinality. And now let us talk about the cross filter. So before we go and understand the cross filter, I would like to take some visualizations into the picture. For understanding, I'll take some visualizations. So what I'll do is, I'll from the fact table, I'll take product ID. See, the moment I have selected, it is giving me a visualization. Okay, we'll understand visualizations in the coming topic, guys. For time being, let us understand data models. Yes, I got product IDs, different product IDs. Yes, along with the product IDs, I would also like to get the quantity for each and every product. I got it. But I got the product ID. I don't know what is the product name. I don't know what is the product name. Let me take the product name from product table. Can I? Yes. Yes, we can take, you know, the columns from different tables. The reason why fact table is related with product table. It is related with product table. So I can have the columns from other tables as well. Now, next to it, I'll have quantity. Okay. And finally, the total amount that we have got from each and every product. So I'll talk about more about visualizations in the coming topic, guys. Not today. Okay. Because this is not the time for talking about visualizations. We are here to understand the data models. Okay. How are these getting loaded? What are these called? We'll talk about more about the visualizations in the coming topic. Not today. I have loaded 4 different columns. Okay. Product ID, product name, quantity, and the total amount that we have received from each and every product. Now, I'll also take the category to which these products belong to. The categories to which these products they belong to. And the product names. Yes. The product names and their categories. Assume this is what I have. Okay. What are these called? These are called tiles. We have discussed, right? Within a report, within a page, each and every visualization is called tile. Right? Now let us understand what is this cross filter direction. Okay. So we know that within a report, within a page, nothing but within a report, the charts interact, the tiles interact. Yes. Let me try interacting. Okay. I'll select only one specific product from the first tile. Is it interacting with the second tile? Yes. Immediately it is interacting with the second tile. See? It has filtered only the water bottle. The product water bottle got filtered. Let me select the same water bottle from the second tile. It has interacted. Yes or no? Yes, it has interacted. Now, let me remove the product name from the first tile. Let me remove the product name from the first tile. Let us do it. So, I have two different tiles in which the first tile represents all the statistical information and the second visualization gives me the descriptive information, because we have product IDs and the product names and to which the category they belong to, the total amount that we have got and the sum of the quantity, the number of pieces or the number of units that specific product got sold. Okay, now I'll do the same. I don't know what is product ID 112 means. I'll just try to filter 112. It is not filtering. See, I have selected 112, but it is not filtering. Fine. Let me do the same here. I'll select, I just want to know the product ID and the information for running shoes. I'll select running shoes, but this filtered me, in the other direction. When I have selected one product from the second visualization, it is allowing me to filter. The record got filtered. The product ID for running shoes is 106. The amount that we got is $1082. Number of pieces running shoes got sold 22. I'm able to get the information. But why not in the reverse direction? 112. See, if I'm selecting, it is not a filtering. Why? This is because of, the direction that we have between the fact table and the product table. Towards which direction you see the arrow mark pointing? Towards the fact table, right? So that means it allows only the filtering in one direction. By default, the filtering will be done only in one direction. How can you change it to both? Is when you right click on it, when you right click on the connection, the relationship, you get delete and properties as two options. When you click on delete, this will delete the relationship. So don't delete it, click on properties. When you click on properties, there is an option called cross filter direction. Ensure this cross filter direction is both. When you keep it as both, you'll see the arrow mark pointing in both the directions. See, in both the directions, it allows me to filter. Now, if I go back, if I do the same, it allows me to filter, guys. See, is it 106? Yes. So that is how I can filter the records in both the directions. But earlier, I'm unable to filter. It is because of the cross filter direction. Making sense? So do the same for all the connections that are available. For all the connections, ensure the cross filter direction is both. Done? I'll do the same for customer table and fact table also. I'll keep it as both. I'll click on save. And finally, coming to dates and fact table, I'll be doing the same. So you should observe the arrow mark between the tables. Within the relationships, they should be identified as both. In both the directions, the filtering will be done. Right. So earlier, we tried to establish the relation between dragging the common column. Right. See, how did we establish the relation between dates table and fact table? By dragging the date ID to the date ID of fact table. That has created a relation, right? But is there any other option or is there any other approach? Yes, we have also other approach. How can we create the relation between two tables manually? If Power BI fails to create a relationship, how are we supposed to do it? Is under the home tab, especially you have to go to the model view. Within the model view, within the home tab, you'll see manage relationships. There is an option called manage relationships. Click on manage relationships. Okay, so it will actually give you the options like new relationship, auto detect. When you click on this auto detect, Power BI being intelligent, it will detect the relationships in this fashion. Like how it has detected, in the same way it will detect the relation between product table and fact table. Okay, so it will not click on auto detect. I'll go and click on new relationship because I'm going to create the relationship manually. So select the table first of all. The first table I will keep it as fact table, and to which table are we going to connect? Product table. See, Power BI being intelligent, it is capable of identifying the relationship. I mean the common column was identified. In cross filter direction, keep it as both. And then click on C. That's it guys. Okay, so it's up to you whether you want to close any relationships, if you want to delete or if you want to change. Okay, so when you select, it allows us to delete or edit the relationships. Okay, whether the status of the relationship is active or inactive, everything will be displayed under the manage relationships window. Okay, then you can do the necessary changes. Once if you are done, close the window. Right? So this is all about data modeling. Okay, so which helps us to create the models, which helps us to create the relationship between the tables, the normalized data. Okay, so in general, you will have the data stored in this fashion, the normalized fashion only. The main purpose of it is to reduce the redundancy. You're going to reduce the redundancy on the data. Clear? Yes. So we'll understand more about the data visualizations in the coming topic because this is not the right time to talk about these visualizations. Okay, so I'll be explaining how did we create these visualizations, what are these visualizations called in the next coming classes, upcoming classes. Right. Yes. So friends, if you have any questions, yes, feel free to post your questions related to the data modeling, Power Pivot. In the upcoming sessions, we'll talk about DAX. Once after completing DAX, we'll also go with, you know, data visualizations. Power BI is all about visualizing the data, right? So we'll be talking about the visualizations, how to create visualizations and the purpose of each and every visual. So it's time for our questions. Any questions? And by the way, if you find that the session went well, do hit on the like button. Also share across your connections. Ask them to learn Power BI, guys. The same data sets are available in Kaggle. They are available in Kaggle, guys. Just download them. Yes, we have provided the feedback link. Give your valuable feedback before you leave and ensure that you have subscribed to our channel. As a kind of encouragement, do hit on the like button and utilize this good amount of time for your questions. Any questions?